Alright guys, today we're going to be talking about the properties of log functions. So up until this point, we have been talking about taking the inverse of log functions, taking the inverse of exponentials, okay? And we know that the inverse of an exponential is simply going to be a log function. Alright, so getting into the properties of log functions now. This isn't too bad as long as you remember the properties of exponents, okay? So I'm going to do a brief little rundown of the properties of exponents first, and then we'll go into the properties of logs because they're related, right? And they're very similar. Okay, so for example, I'm going to use variables here. I have a base of x, and let's say I have the power of a. And if I'm going to multiply another base of x, then we'll say power of b here. Well, based on properties of exponents here, we know that if we have the same base and we're multiplying, we're going to add the exponents here. So I can write this as x to the a plus b. Again, this is going back to algebra 1, okay? Well, what if we divide, right? If I do x to the a divided by x to the b, well, in this case, we're going to subtract. Again, they're the same base, so we can do this, x, a minus b. Again, these rules only apply when we're dealing with the same base. Okay, so that's very important, right? And again, we could go back and forth. If it was written like this, we could put it into this form, right? If we saw it written like this, we could put it into this form. Okay, we can go back and forth between the two. Now, if we have a power to a power, so if we have x to the a, and then raised to the b, we know that this is simply going to become x times a times b, okay? Alright, so going over that basic review, let's go into the properties of log functions. Now, we're not going to go over all the properties, we're only going to go over the product, the quotient, and the power property. So the product, the quotient, and the power property. We are not going to go over, in this video, the inverse or the change of base. That will be for another video. So in this video, we're only going over the product, quotient, and power property. Okay? So first one we're going to go over is product property. So let's write this out. Product property. Alright, and let's see what this looks like. So if we have, let's do a basic example here, log base 3 is 1,000. Alright, so I want to try to evaluate this by hand. I don't want to use a calculator. Now, how could I do this? Using the properties of logs. Well, using that same knowledge of the properties of exponents, we're going to apply this here. And what I want you to think about is how can we rewrite this on the inside? Mathematically, how can we rewrite this so it's still the same? Well, I could write this as log base 3 and then do 10 times 100, right? That is the same thing, right? That's the same thing that we have written here. And if I go a little bit further with this, we know that I'm multiplying here. I have the same base, so essentially what this looks like, I have log base 3 to the 10 times log 3 to the 100. Again, this is just basic distribution here, right? We're multiplying, right? So if we're multiplying these two, okay, so the first example we're going to go over here is the product property of a log function. So product property, okay? So for example here, if I have log base 3 of 1,000, okay? How could I rewrite this using the properties of log functions. Well, what I want you to think about is how can we rewrite mathematically this 1000 right here? How could we rewrite that? So if I did log base 3, I could say here 10 times 100. Okay? And notice here that I had the same base and I'm multiplying. We know that when we multiply and we have the same base that we add. So I can rewrite this as base 3, 10 plus log base 3 of 100. Okay, and this is the same as this, all right, in properties of log functions. So that is the product property, okay? Let's do another example. Our next example will be the quotient property. So we're going to go ahead and write that out, quotient property. And again, we're talking about division here. So the quotient property of log function. So for example, if I have log base 5, and let's say we're doing 16 divided by 2. Well, again, we're dealing with the same base here. Okay? We're dividing, so we know that based on our properties of exponents, going back to that, when we're dealing with the same base and we divide, we know that we're going to subtract here. So we have log base 5, 16, right? And then minus log base 5, 2, right? And that is done, alright? So this right here is the same as this. Okay? Let's go on to the power property now. And that will be it, and we'll do some real life examples. Alright, the last property we're going to cover in this video is the power property. So here we're going to write power property. Okay, and let's go ahead and do an example here. So if we have log, let's say base 10, all to the 10 to the third power. Okay, well, we need to think about how we can rewrite this. So I have 10 3 times here, so essentially what this is saying is log base 10, 10 times 10 times 10. Alright, well, going back again, same base, alright, and we're multiplying. Well, we know here that we're going to add. So we do log base 10, 10 plus log base 10, 10, and then plus log base 10 of 10, okay? And then if you were to combine each one of these, right, because we can, this would be 3 log base 10 of 10. Now, an easy way to remember the power property when you're dealing with log functions is to simply just bring it down to the front. So for example, all you had to do here was bring this guy down to the front and you would have been done. Alright? But this is why it's happening mathematically. Okay? So what we're going to do, we're going to combine all these examples now and we'll do some extra problems here. Alright guys, here's our first example. So we have log base 4 of 2 plus log base 4 of 32. Now what I want you to do is evaluate this by hand, okay, using the properties of log functions. So recognize what's going on here. We're dealing with the same base, okay, and we know that when we're dealing with the same base and we multiply, we add. Well, we're going in reverse now. We're dealing with the same base and they're adding. So we're going in reverse, so that means we need to multiply here, okay? So again, if I rewrite this now, it's going to become log base 4, and this is going to be 2 times 32. And then going a little bit further, log base 4, this will be 64, okay? And then going to our equations that we use for log functions. functions, here it is written in its log form, y equals log base of x, which I have here. I'm going to put equals y. So y equals log base 4 of 64. When we want to evaluate this, we put it into its exponential form. So we simply rearrange this now using this. So this becomes 64 equals 4 to the y power. What do I need to plug in for y now in order for this to equal 64? Well, in that case, it's going to be 3, right? 4 to the third power will be 64. So your answer here would be 3. You need to put in a 3, right? So again, we just evaluated this using properties of log functions. So let's try another one. Okay. So example number 2, we could have log base 5. This will be 625 plus log base 5, and we'll do 25 here. So again, we're dealing with the same base, okay, and we're adding. So again, go back to your properties of exponents. Remember, when you're dealing with the same base and we multiply, we add the exponents. Well, we're just going in reverse now, right? We're dealing with the same base and we're adding here, so we're going to multiply. Okay? So I can rewrite this as log base 5, and this will be 625 times 25. Alright, going a little bit further, we get log base 5. And let's use our calculator here. 25 times 625 is going to be 15,625. Okay. Again, using your equations up here, here we are in our log form, so we have y equals, okay. Let's put it in its exponential form. So doing that, we'll have 15,625 equal to 5 to the y power. So what do I need to plug into y in order for this to equal 15,625? So you're probably going to need a calculator for this one, but if you put in a 6, alright, this will equal out. So your answer here is 6. Okay? So again, that was going over the product property. Let's do some examples now of using the quotient property. So here is our next example, and we're going to be dealing with the quotient property now. So notice that I'm dealing with log base 2 of 32 minus log base 2 of 4. So again, I have the same base here, and just going back to the properties of exponents, when you're dealing with the same base, okay, and you divide, you subtract the exponents. Well, in this case, we're just going in reverse. We're dealing with the same base, and we're subtracting, so that means we need to divide here, okay? So I can rewrite this as log base 2, and this will be 32 divided by 4. Going a little bit further, I can have log base 2, 32 divided by 4 is going to be 8. And then using your equations up here for log functions, right now I'm in its logarithmic form. So y equals log base 2 of 8. Putting it into its exponential form, I can evaluate this. So doing that, I'll have 8 equals 2 to the y power. So what do I need to plug in to y here in order to get this whole thing to equal 8? Well, that's going to be 3, right? 2 to the third power is 8. So your answer here will be 3. So again, we just evaluated this using properties of logs. Let's try another example. So again, sticking with the quotient property, we'll have log, we'll do base 7, let's do 49, and then we'll do log base 7 of 7. Okay, so let's go ahead and evaluate this using properties of log functions. So taking a look at this, I know that I'm dealing with the same base, okay, and I'm subtracting. So in this case, I must be dividing, right? So I can rewrite this as division, so I'm going to write log base 7, 49 divided by 7. All right, let's go ahead and do this. 49 divided by 7, well, that's going to be 7. So we get log base 7 of 7. Here it is as its log form. So y equals log base 7 of 7. Let's put it into its exponential form now. So what do I need to plug into y in order for this whole thing to equal 7? Well, 7 to the first power will be 7. So in our example here, our answer will be 1. Right? So that is the quotient property. Let's go on to the next example. Okay, here's our final example. We're going to be dealing with the power property of log functions. So again, just going back to the first part of this video, remember when you're dealing with a power, a really simple way to do this is to just bring that power down to the front. That's all you have to remember. Bring it down to the front. Okay, so that's what we're going to do here. So when we rewrite this, we'll have 2 log base 3 of 81. Okay, and what you want to do at this point is isolate your log. So we're looking at this part right here. Let's just evaluate this part here, okay, and then we'll worry about this too. So looking at this, I can write this as y equals log base 3 of 81. Let's put this log function into its exponential form. So in this case, we'll have 81 equal to 3 to the y power. Now what do I need to plug into y here in order to get 81? Well, that's going to be 3 to the 4th power. 3 to the 4th power is 81. So this whole part right here, when we evaluated it, is 4. So knowing that, we can rewrite this as 2. Now here comes this whole part that we just evaluated, 4. And we know that 2 times 4 is 8. And that's it. We just evaluated this log, okay, using properties of log functions. This is your final answer right here, 8. Okay, let's try another one. Let's do log base 5. Okay. And we'll do 1 over 5 all to the 3rd power. Okay, so again, this is going to be a power property, right? So we know that we need to bring this down, okay? Make it simple on yourself. See a power, just bring it down to the front. So we're going to go ahead and do that. And we'll have log 5, base 5, 1/5. Okay, again, let's just evaluate our log function, so this part right here, and then we'll worry about this 3. So looking at this, I can rewrite this, right? This log can be rewritten as, make an arrow so we can see, I can write log base 5, and then I have 1 over 5. Well, I can rewrite that as 5 to the -1, right? And then again, I'm going to have another power property here, right? So let's go ahead and bring this -1 to the front. So when I do that, I have -1, okay, and then I have log base 5 of 5. All right, let's isolate this log right here, okay? And when we do that, looking at our equations, right, we can rewrite this in its exponential form. So this guy right here can be written as y equals log base 5 of 5, right? And when we put it into its exponential form, right, well, this is going to become, we get 5 equals 5 to the y. And now we say to ourselves, well, what number do I need to plug into y here in order to get this to equal 5? Well, this is simply going to be 1. So this whole thing right here becomes 1, okay? So we know that log base 5 of 5 is 1. Now multiply by -1, so we get -1, okay? So now that we're at -1, okay, going back to this, we know that this whole part right here, okay, is going to be -1. So when we do 3 times -1, okay, this will equal -3. Alright? So that is your final answer there. Now I'm going to show you another way you could have went about doing this. Okay? So your answer here was -3. Let's show another way you could have done this problem. So again, bring down the 3 like we normally would. Okay? And let's just evaluate this part right here. But we're not going to rewrite the 1 over 5 as 5 to the -1. We're going to leave it as is. So for example here, we can rewrite this as y equals log base 5 and then 1/5. Okay, here it is in its log form. Let's put it into its exponential form. So when we do that, we're going to get 1/5 equals 5y. Well, what am I going to need to plug into y here in order to get 1/5? Well, it's going to have to be -1, right? Because 5 to the -1 is equal to 1 over 5, right? So knowing that, right, my answer here will be -1. And then simply going back now, since we just evaluated this part, we're doing 3 times, which we just evaluated, we determined it was -1, and we get -3, so the same thing. So a couple ways you could have went about doing this, all right? No right or wrong way, just how you might have seen it, okay? So again, this is kind of the basic rundown of the properties of log functions. All right, this will be a 2-part video. The next video will be on talking about the change of base and the inverse property of logs. Okay, so in this video we covered the product property, the quotient property, and the power property of log functions.